In section 2, we talk about the angle properties in triangles. Now, of course, by the time that we get to grade 11, we should hopefully know that the total degrees in a triangle should be 180. Meaning you add up all the angles, it should equal 180. In section 1, we talked about exterior angle, though really right now is when we're going to really tie into it. We're going to actually connect things together. So we talked about the exterior angle of a polygon. Now, that is the angle formed by the side of a polygon and the extension of an adjacent side, which means if I extend this side off, the angle made with that side and that extended adjacent side is known as the exterior angle. If I build off of this side with this triangle, if I'm going to do that same thing here, I'm going to build it off in the exact same direction on either one, meaning that I'm going to have exterior angles there and exterior angles there. That's just what an exterior angle is. So in our first example, we'll talk about triangle ACD. It states that AC is equal to AD. Now, when we say that, we usually write a nice little line saying, yeah, they're equal, identifying that that side is the exact same as that. What we're going to do is we're going to prove that angle ACB, so that angle, is equal to angle ADE. The biggest thing that we need to know, though, one of the biggest things, that is one line. Same thing right here. This is one line. Well, the beautiful thing about that is that angle ACB, if we were to add this angle right here, which is angle ACD, that would equal 180 degrees, because 180 degrees is one line. Similarly, if we took angle ADE and we added this angle, angle ADC, it would also equal 180 degrees because it's also on a straight line. Since they are both equal to 180, it means that this should be equal to this. So if we took angle ACB and add angle ACD, it'll equal angle ADE, adding, make that look a little bit nicer, angle ADC. Now I put a little reminder here for myself just to state one specific property. If this side AC is equal to this side AD, it means that is known as an isosceles triangle. And one of the key properties of an isosceles triangle, which you'll have to know, is that the sides and angles across from them will always produce equal angles. So what I'm saying is angle ACD is actually equal to angle ADC. So if ADC or ACD and ADC are both the same, this is what this looks like. I try and leave things as color-coded as possible. But since ACD is equal to ADC, and this side is ADC, well, I'm really just adding angle ACD. The beautiful thing is, if you have the exact same thing, well, we could subtract them off. And if we subtract them off, well, they're gone. They're zero, which means that we are left with angle ACB equal to angle ADE, which is exactly what we tried and wanted to prove. Now, using that same kind of terminology, we're going to do some more specific things here. Now, I'm going to start off with one thing and then tie it in and make it a little bit easier. What do we know about, first off, the angles or the degrees in angles in a triangle and angles on a straight line? Well, you know that those two things add up to be 180 degrees. We also know that all of these angles add up to be 180 degrees. So let's call that y. X plus y equals 180 degrees. We also know that in this triangle, y plus 64 plus 45 also equals 180 degrees. Well, since they both equal 180 degrees, it means that x plus y actually equals y plus 64 plus 45. And if we go further, well, we could subtract y from both sides, meaning x is 64 plus 45, which means it's actually 109 degrees. Of course, then we could go process elimination, say that y is 81. There's multiple ways of doing this. The reason I'm showing this one is because it's actually tying back into that first definition that we talked about today. This exterior angle of a polygon. Now, it's more specific, the exterior angle of a triangle. The exterior angle of a triangle equals the non-adjacent angles. Actually make that look like a J. Now, it's a special property. Typically, I don't expect you to memorize it because you can derive it actually just through trial and error. It's just a very quick way of doing things. So what I'm saying is, in this entire situation, the exterior angle made off of this unknown side will always equal these two angles added together. Which means if I have this question, this is my exterior angle, which means it's actually going to be these two angles added together. So if we do this question, we can say that 5y add 3, adding 4y add 8, would actually equal 146 degrees. And further, we can combine our like terms. And just keep on going. Subtract our 11. 9y would equal 135. Dividing by the 9. Y equals 15. There's our variable. We have another thing that fits that exact same procedure. This is the exterior angle of this triangle, which means it's going to be these two angles added together. In this case, say 9x at 16, adding a 6x at 15. Combine our like terms. Do some wonderful manipulation. So what do we get? We get a negative 4x equaling to a negative 28, divided by the negative 4. And x equals 7. Now we're not limited to just talking about exterior angles. Well, we can also talk about a whole bunch of other properties, including the ones when we talk about parallel lines and all of these exterior angles. Now, as I've stated in our first section, I don't care how you solve it. You can solve for one thing, then the next, and one thing, and then for the other. In this first one, you could solve any of these angles first. I can, well, just to prove that, I'll go in reverse order. D. Well, D is on a straight line, which means if I take 180, subtract the 57, subtract the 64, I get 59. The property that I just used there, it's the property of a straight line. If I ask you to be specific, I do expect that you are being specific. So I can solve for C. Again, you are not limited to just going one way. I'm just proving the fact that I can solve for any of these angles in any way. So, meaning C. Let's see, it is on same side interior angle to 64, which means same side interior angles are always supplementary, always add up to 180, which means if I take 180 and subtract my 64, I get 116. They are same side interior. I don't mind abbreviations as long as they actually make sense. See, what about B? Oh, sorry. One thing, it's same side interior to the 64-degree angle. I do want you to be very specific. So angle B, well, it's also going to be 64. Why? It's an alternate interior to the 64-degree angle. And A, well, let's see, there's multiple ways of doing it. For example, B and D and A would add up to 180. So if I just took 180, subtracted my 59, subtract my 64, I'll get 57. Where else is 57? Right here. Well, that means I could use a simpler property. It's alternate interior to the 57-degree angle. I could have solved any of these in any order using even different properties. As long as it's a correct property, it all works. Next one, we can have some more fun. Let's see, I'll start with A. Well, A is going to be 58. Why is it going to be 58? For some reason, I really like alternate interior angles. See, I could use C next. Well, in order to calculate C, I have to take 180, subtract 48, subtract 58. To give me 74. Well, why am I using that? It's a triangle supplementary property. A triangle adds up to be 180. Next up, let's go B. Well, I could use it as being alternate interior to the 48, or I could say it's the straight line supplementary property with C and A. So I'll go the long way this time. Let's see. 58, subtract the 74. Oh, I type that in my calculator and I get 48. Sorry, that doesn't actually need a dot there. It's a straight line supplementary property. But I'm going to be specific with C and A. I should have also done that up here with the 57 and 64. Even though it is in our formula, I still want to be specific. Well, I'm going to have some more fun. Let's see, to calculate angle D. Well, let's see, angle D is an exterior angle to these two. So if I just take 48 and add 74, it would have to be 122. It's the exterior angle of a triangle. And the last example, there's multiple ways of doing it. Let's see. I'll start with B. Because, well, if I take 180 and I subtract my 107, I get 73. Well, why is it 73? Oh, make that look like. It's a straight line supplementary with the 107. See, I can go G. Well, G is also going to be 73. Why is it going to be 73? It's vertically opposite to B. Vertically opposite angles are always going to be equal. And let's have some fun. Let's go C next. Well, see, I could deal with same side interior. Well, same side interior angles are supplementary. So it's a same side interior to the 107. Absolutely, we could say that it's an alternate interior to angle B. More than one way of doing it. Let's see, let's see, angle F might be a little bit trickier. No, it's not. Angle F is going to be 45. Why is it going to be 45? It's a corresponding angle to the 45-degree angle. See, I'll keep on going around. Well, angle E. Angle E, if I took 180 and subtract my 45, I get 135. Why am I doing that? Because it's a straight line. It's a straight line supplementary property with angle F. Let's go A next. There we go. That's actually right. Let's see it. It's vertically opposite to F. It's going to be 45. I could say it's alternate interior to the 45. Both perfectly fine. But it's vertically opposite to F and D. See, I'll go with the general triangle supplementary property. If I took 180, subtract the 45, subtract angle B, which is 73. I get 62. It's triangle supplementary with the B and the 45. And there we have it.